Hello, welcome back, and thanks for clicking on another Unarculus production. Today, we are going to talk about the trapezoidal and midpoint rules, two additional ways that you can approximate the area underneath a curve in addition to the left endpoints and the right endpoints that we've already learned. All right, so let's get started. Okay, it shouldn't take too long to do this. The first rule we're going to talk about is the midpoint rule. Okay, so the midpoint rule involves you using the midpoints of each rectangular base to calculate the height of the rectangle. All right, so let me show you the difference between the midpoint rule and the left endpoints and the right endpoints that you already use rectangles for. So let's say I had a curve, okay, whatever, we'll call it f of x. And let's say I started my interval at, we'll start at 0 and we'll stop at 4, let's say. Okay, and we'll use 4 rectangles of equal width. All right, so that makes delta x b minus a over n. So that's going to be 4 minus 0 over 4, which is 1. So I'm going to go 1 unit. So from 0 to 1, from 1 to 2, from 2 to 3, and from 3 to 4. Now, normally when we did, when we first started, we worked with left endpoints and right endpoints, which means that we started from like the far left, okay, and then drew our rectangle across this way and down, or we started from the far right when we used right endpoints, drew across backward and down to 3. Instead, you're going to use the midpoint. So basically what you're going to do is each one of these bases, you have a base from 0 to 1, okay, that's the base of your first rectangle. You're going to find the midpoint between those 2 points, which is, of course, a half. Now you're going to go up to a half, draw your height, draw across this way, and down. That's rectangle number 1. Then we're going to go over here to 3 halves. Okay, put your point there, draw across this way. That's rectangle 2. Now you're going to go over here to 5 halves between the 2 and the 3, the midpoint. Draw across this way and across this way. That's rectangle 3. And then finally, you're going to go to 7 halves, go up here, draw across this way and across this way, and that's rectangle 4. And you can see what you've kind of accomplished here compared to left endpoints and right endpoints. You now have rectangles where some of the rectangle is too much, but there's also some missing. So what you're kind of hoping is the fact that the amount that's missing is equal to the amount that's over, and then you'll get a true answer or a very close approximation. And you actually do get a very good approximation. Okay, you actually do get a very good approximation. It's not exact. All right, it's not exact, but it is an excellent approximation. Okay, all right, so that's how this would work. All right, and then when you were calculating your areas, the area, for example, the first one would be 1 unit for the base. The base is the entire unit, okay, times f of 1/2. And then the next one would be 1 unit from 1 to 2 times f of 3/2. And you can continue on like that. All right? All right, so let's try one together here real quick. Make sure that you got the idea and you understand how it works. So let's take f of x to be 4 minus x squared, okay, on the interval 0, 2. We'll use 4 rectangles of equal width. All right, so when you're using midpoints, the rectangles really have to be of equal width. Okay, otherwise the whole thing kind of falls apart. So 4 minus x squared is a parabola that opens down. That's 4. This point here is 2, because if I plug 2 into f, I'll get 0. Okay, and now delta x would be b minus a over n. So that's going to be 2 minus 0 over 4. So that's going to be 1/2. So I'm going to go 1/2 between each unit. All right, so let's start here. We got starting from 0. Here's a half. Here is 1. Here is 3 halves. And then we have 2. Okay, now we are going to find the midpoints of each one of these. So the midpoint between 0 and 1/2 is 1/4. So we're going to come up to a quarter, find the height there, draw across this way and down this way. That's rectangle 1. So now between a half and a quarter is 3/4. Draw up here, across this way. That's number 2. Then we have 1 1/4, right, which is 5/4. Draw across this way and down. That's number 3. And then we have 1 3/4. So we put a point here, draw across this way. Oops, I missed. Okay, that would be rectangle 4. So to calculate the area with the midpoints, we would take 1/2, which is the base of the rectangle, right? The whole base is a half a unit, times f of 1/4. The next one would be 1/2 times f of 3/4. Then we would have 1/2 f of 1 1/4. And finally, we would have 1/2 f of 1 3/4. Okay, and to find f of a quarter, f of 3/4, f of 1 1/4, f of 1 3/4, you take, for example, f of a quarter, you'd plug it in, you get 4 minus 1/4 squared, which would be 3 15/16, right? That's what you would get. So then you take 1/2 times 3 15/16. So I'm not going to belabor this. We could do it all the way through. All right, but I'm not going to go all the way through here. Okay, there's all sorts of fractions. I just want you to understand how to set it up. All right, so that you could do it if you were asked. Okay. All right, so let's see what else we have. Okay, so here's one with a chart. All right, same idea. So the function is continuous on the closed interval 0, 12 and has values shown above. So from 0 to 12, it wants you to use a midpoint Riemann sum, 4 subintervals of equal length, to approximate the area that lies under f and above the x-axis from 0 to 12. Okay, so to find our delta x, we would take b minus a and over n. So that's 12 minus 0 over 4, which is 3. All right, so now my suggestion to you is always, look, just map it out on a graph here. So we're starting from 0, we're stopping at 12, we're going by 3 units. So 3, 6, 9, 12. Then just draw anything. It doesn't matter what it looks like. Okay, that's totally irrelevant. All right, and then you're going to actually go and try to find the midpoints here. So the midpoint between 0 and 3 is 1.5. You draw across here and down, that's number 1. Between 3 and 6 is 4.5. Again, notice that all these numbers are conveniently located in the chart. That's number 2. Between 6 and 9 is 7.5. Okay, that's the midpoint of the 2. That's number 3. And then we have 10.5. That would be rectangle 4. So now if you want to find the area of the first rectangle is 3 units for the base all the way across times f of 1.5. The next one will be 3 units across, f of 4.5. Okay, the third one is 3 units across, f of 7.5. And then finally, the last one is 3 units across, f of 10.5. And again, notice the fact that although all these numbers are in the chart, there are a lot of x values. We only used a few of them. Okay, so there can be more x values than you necessarily need. And then you would take the numbers from the chart. So it would be 3 times, that's 1.45. These decimals kind of look like decimals. They're not. Okay, they're just typos. I don't know what they are actually, but they're not decimals. The next one is 3 times 5.05, and then you do 3 times 12.25. And finally, 3 times 23.05. Add them all together, and that gives you the approximate area. All right, I'm not going to do it. It's a waste of your time. Okay, but that's how you would get it. All right, that's how the trapezoidal rule works. Okay, now it's your turn. All right, now let's go on to the trapezoidal rule. I think I may have just said trapezoidal rule a minute ago. but the midpoint rule is what we were talking about a minute ago. All right, so trapezoidal rule involves you using trapezoids, obviously, instead of rectangles to approximate the area. So let me show you what that looks like. Okay, the first thing you have to remember is that the area of a trapezoid is 1/2 the height times the sum of the two bases. Okay, half the height times the sum of the bases. The bases are the parallel sides. All right, there are the two sides that are parallel. Okay, so for example, let's say I had this curve here. All right, we'll start from 0. We'll stop at 12. I don't know. We'll say delta x will be 12 minus 0 over, let's say, 4. So we'll make only 3 of them. Oh, no, let's say over, now let's do it the other way. Let's do 3. Then we can go in 4 units. Do it a little faster. 12 over 3 is 4. Okay, so we got 4, we got 8, we got 12. Okay, so now here's how you draw your trapezoids. All right, so we're starting from 0. Okay, you're going to put a point on f of 0. Here's f of x. We're going to put a point on f of 0. We're going to put a point on f of 4. We're going to connect the two. Draw down and down. That's trapezoid number 1. Okay, then we got a point on f of 4 already. We're going to put a point on f of 8. And that's number 2. And then we're going to put a point on f of 12, and that is number 3. Okay, so what you have is you actually have right trapezoids, right? You have trapezoids that have right angles in them. Okay, the bases of the trapezoids are the parallel sides. So it's a little confusing because these are the bases. These are the sides that are parallel to one another, even though they're standing up. The height is what we would consider to be the base of the rectangle, right? That's going to be the height because the trapezoid normally, if you see it on a piece of paper, would sit like this. Okay, here's your base, here's your base, here's your height. But instead, it's standing up on the height. All right? So to calculate the area of this thing, the area of the first one would be 1/2 the height. The height in this case is 4 units. That's the height. Times the sum of the bases. The sum of the bases would be f of 0 plus f of 4. Okay. The next one would be 1/2 of 4, f of 4 plus f of 8. And the last one would be 1/2 of 4, f of 8 plus f of 12. All right. And then you just do the math, whatever it is, and you add them up. And you'll have an approximate area. And you can see the nice part about the trapezoids are that they fit nicer to the curve usually. So there's not usually as much excess or not as much that's just missing. Okay? All right, so we're going to try one here coming up momentarily. All right, so let's just we'll go back to our old faithful here again. We just did it a minute ago. Let's try 4 minus x squared, okay, on 0 to 2. We'll use, let me see, use 4 trapezoids, I guess. All right, we'll use 4 traps. So delta x in this case is going to be 2 minus 0 over 4. It's going to be a half again. So here we go. So here's my 4 minus x squared. Here's 2. Here's 0. And we're going 4, right? So we got 1/2 a unit, a half, 1, 3 halves, 2. Okay, here we go. Draw the traps in. So on f of 0, you're going to put a point. On f of a half, you're going to put a point. You're going to cross this way and down. This one kind of looks like a rectangle because the way I drew the curve. That's number 1. This one will look more like a trapezoid. All right, there you go. That's number 2. Then we got a point already on f of 1. We got a point now on f of 3 halves. That's trapezoid number 3. And then we have a point here. And that is trapezoid number 4. All right, so this one's a little funky, and we'll talk about it momentarily. It's a little bit weird. Okay, obviously. It's trapezoid number 4. We'll talk about how you would do it momentarily. So the area of the first one is 1/2. So the area of any trapezoid is half the height times the sum of the bases. You got to know that. Okay, you got to know it off the top of your head. It's going to be on the exam. So 1/2 of a half, f of 0 plus f of 1/2. Next one is half of a half again, right? The height is this way. F of a half plus f of 1. The third one is a half of a half, f of 1 plus f of 3/2. And finally, the one that we're most interested in, I guess, is a half of a half, f of 3/2 plus f of 2. Okay, now you can calculate all these values like f of 0. You can calculate, just plug it in. 4 minus 0 squared, you get 4. This value is equal to 4. Okay, and you're just doing the math here. That's all. Very simple. You're going to add them all up. The one that's most interesting to everybody is this bottom one, right? The fourth area. F of 2, if you calculate it, you get 0, right? But that actually should make sense. This thing actually washes out at 0. And what you get is you get 1/2 times 1/2 times f of 3/2, which makes complete sense because this is a height, this distance is a half. This distance is f of 3/2. So what you actually have is the area of a triangle, which is 1/2 the base, which is a half a unit, times the height, which is f of 3/2. Okay, it's actually not a trapezoid, it's actually a triangle, but we just did it with the trapezoidal rule. All right, so that's how that one turns out. Okay, but the rest of them, pretty simple. All you got to do, just do the math, plug them in, and you'll see what you get. All right, you just have to know how to draw them. Okay, all right, let's see what else. Okay, so let's try this one real quick. Another one here with a table. All right, so this one's important. The function f is continuous on -1, 9, closed and has values. It wants you to use 4 subintervals, trapezoids. Okay, we want to use traps to approximate the integral from -1 to 9 of f of x dx. Okay, this means the area under the curve. Spoiler alert if you're watching it before we do it. Okay, that's exactly what it means. It means calculate the area under the curve, the integral from -1 to 9. All right, so we're going to use traps to do this. Okay, so let's go ahead and do it. Again, just draw anything. It doesn't matter. Put your points on there as they are. So let's just, whoa. All right, let's try that again. Sorry. That's not going to work. All right, so we're going to start on -1. Fine, it doesn't matter. Start on -1. 1, 4, 6, 9. Okay, here's your curve. Again, it doesn't matter what it looks like. All right, so here we go. Put a point on -1, put a point on 1, draw across this way and down. That's going to be trapezoid number 1, even though it doesn't look like a trapezoid. Put this point here, across and down, that's number 2. On 6, across and down, that's 3. On 9, across and down, that's 4. Here we go. So the area of a trapezoid is 1/2 the height times base 1 plus base 2. Let's go ahead and do it. The area of the first trapezoid is 1/2 of 2. 2 units is the height. This distance is 2. Okay, f of -1 plus f of 1. Next one. I'll leave some space there so we can actually calculate that one. You can see me do one. F of a half, it's a half. The height is 3. F of 1 plus f of 4. Next one is 1/2 of 2, f of 4 plus f of 6. And finally, 1/2 of 3, f of 6 plus f of 9. Okay, so we'll just calculate this one up here real quick. Half of 2 is 1. F of -1 is 12. That's supposed to be a 12, not a 0.12. So it's 12 and then f of 1, so this is 12 plus f of 1 is 9, so that's 21 times 1, 21. So the area of this first trapezoid is 21. Find the area of the other three, add them all together, you get the approximate area. And the one final thing I'll say before we go to the last question is the following. You do need to be careful. There are textbooks that will teach you the trapezoidal rule, okay, using a formula that says this. F of x0 plus 2f of x1 plus 2f of x2 plus ... You can do that for a while. 2f of xn minus 1 plus f of xn. Okay? This formula cannot be used on the exam because this formula is assuming the fact that all of the heights are going to be the same. And if all the heights are the same from each one of these formulas, okay, now our heights here aren't the same, but you can see, but every one of the formulas has the 1/2 in common. You could factor out the half, put it in the front, and then if all of the heights were the same, you could factor those out also. Okay, you could factor those heights out as well, and then you'd be left with, and you can see it on the picture, f of the first value, f of -1 is used once. But then f of 1, all of the values in the middle are used twice. So there'd be 2 f of 1s, then there'd be 2 f of 4s because it would be on 2 trapezoids. Then there'd be 2 f of 6s because it would be on 2 trapezoids. And then the last one, f of 9, would only be used once. So that's what this formula is saying inside. The first and the last one are only used once. All the ones in the middle are used twice. Okay? But the problem is you're assuming that all the heights are the same. And most of the time, if not all the time on the AP exam, the heights are not always the same. So you do have to know the formula for the area of a trapezoid. You got to know it off the top of your head. All right? So that's it for that one. And, what condition or conditions determine whether a trapezoidal approximation is an over or an underestimate? Okay? That is this. It is the concavity. Okay, the concavity is what determines that. So if I put a point here, draw across and down, then put a point here, draw across and down, okay, compared to putting point here, draw across and down, put a point here, across and down, all right. F is concave up, okay, that would be this picture here. F is concave up, the traps are over. If F is concave down, the traps are under. Increasing and decreasing is actually irrelevant. It does not matter. Okay? Both of these functions were increasing. If I draw them decreasing, in this case for trapezoids, it does not matter. You can see the graph. Oops, this graph is, here's the concave up graph. So I put a point here, I put a point here, draw across and down, put a point there, across and down, put a point there, across and down. The traps are still over. If I put a point here and a point here, draw across and down, you can see here that the traps are still under. Okay? So when F is concave down, the traps are under. When F is concave up, the traps are over. Look for that on the exam. They would give you some information to tell you that if they asked you that question, which they will do. All right, now with that, sorry, that was one slide too early. Now it's your turn. Those are not decimal points, folks. Those are not decimals. Those are whole numbers there in that picture. And then when you're all finished, you're all done. And as always, thanks for clicking.